So this is our fifth question. It says that check whether 6 raised to n can end with the digit 0 for any natural number n. So this is like our previous question where we have found out regarding 4 raised to n. Okay, this is a little bit different in the sense that this is 6 raised to n, but the methods are similar. So what we have to do is, okay, we know the theorem, and so we are using some of the sentences from the theorem to solve this. So we know about Euclid's division algorithm, okay, where any positive integer a can be divided by any another positive integer b in such a way that it leaves a remainder r that is smaller than b. And also we know that the fundamental theorem of arithmetic, okay, where the prime factorization of a natural number is unique except for the order of its factors. So here 6 raised to n is given. So if first of all we need to know whether the digit ends with 0. So for that, the basic thing we should know is that if any particular number ends with 0, ends with the digit 0, then it should be divisible by 10. Okay, if any number is ending with 0, that means it should be divisible by 10. I hope this is clear. Okay, so this we can also write this as, if it is divisible by 10, then it should be divisible by, or we can say it should be divisible by 2 and 5. So 2 and 5 are the factors of 10. So we know that 10 is equal to 2 into 5. So if the number is divisible by 10, it should also be divisible by 2 and 10. Now, if we look at the prime factorization, of 6 raised to n, we can write 6 as 2 into 3. Now this 2 into 3 the whole raised to n. So this number, it goes on and on like 2 into 3, 2 into 3, 2 into 3 like that. So there is no mention of 5 here, and so we can write 5 is not in the prime factorization, is not in the prime factorization. So if 5 is not in the prime factorization of 6 raised to n, then what we can say about the 6 raised to n? So we can say that hence for any value of n, 6 raised to n will not be divisible by 5. Okay, so for any value of n, 6 raised to n will not be divisible by 5. So therefore 6 raised to n cannot end with the digit 0 for any natural number n. So this is what we have to write. So hence for any value of n, six raised to n will not be divisible by 5. Therefore 6 raised to n cannot end with digit 0. For what? For any natural number n. So whatever the value of n may be, it cannot be divisible by, it is not divisible by 5, and also, so that means it is not divisible by 10, so that means it will not end with the digit 0. So that's about this particular question. So the structure is like this. So first of all, what we do is we just find out for a digit to end with 0, we should know that it should be divisible by 10. So if it is divisible by 10, it should also be divisible by 2 and 5. In 6 raised to n, we have 2, but we don't have a 5 in its prime factorization. So we have 2 and 3 in the prime factorization of 6 raised to n, but we don't have 5. So 5 is not divisible, or 5 is not in the prime factorization of 6 raised to n. So that means for any value of n, 6 raised to n will not be divisible by 5. So therefore 6 raised to n cannot end with the digit 0 for any natural number n. So this is the structure that you should know. Okay, this is something we already know with our common sense. So what we should know is, we should know how to write it in sentences with the backing of our theorem. So according to the theorem, we know that prime factorization is very unique. Okay, so using that we are solving this. So you should know all the steps and the structure. So first we say how it is divisible by 10, how it should be divisible by 10, and we write the prime factorization of the given number. It's 6 raised to n, so we write the prime factorization. So there we don't find any 5 here, so we just write that. So if there is no 5, that means it is also not divisible by 10. So if it is not divisible by 10, there is no digit with 0 at the end. So that's it. Okay, now moving to the sixth question. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. Okay. So here what you should know is there are two types of numbers. One is prime. One is prime and another one is composite numbers. So for prime, the prime numbers are the numbers that can be divided by 1 and only itself. 1 and itself. This is the prime numbers. But the composite numbers, it can be divided by more than 1 and itself. Or we can say it have factors other than 1 and itself. Have factors other than 1 and itself. Okay, so these are about prime numbers and composite numbers. So if you are taking some examples, you can write 2, 3, 5, 7 and 11, 13, 17, 19. So these are all prime numbers, examples of prime numbers. Composite numbers, you can write like a 4, 6, 8, 9, 10, 15, 14, 12, etc. So these are all composite numbers. So these are the two types of numbers. One number, it is such that it can only be divisible. It is only divisible by 1 and itself. So if you take 19, it is only divisible by 19 and 1. And if you take 4 or 6, it is divisible by 2 or it is divisible by 3. So there are other factors than 1 and itself. So we say that those numbers, composite numbers. So this is the first part of this question that you should know. Now, in the question, it can be observed that, so the first what we have 7. Okay, so 7 into 11 into 13 plus 13. So if you observe here, this is one term, this is the second term. So this we can take in both, we have 13. So we can take 13 outside. So if we take 13 here, the only thing left is 7 into 11. So 7 into 11 plus, here there is only 1 is the factor. So plus 1. So this we can write like this. Now, what is 7 into 11? So this we can write it as 13 into 7 into 11 is 77 plus 1. So that means 13 into 78. Now, this 13 into 78, if you just factorize 78, what you will get is, it's 13 into 78, we can write it as 13 into 6. It's 13 times 6. Now, keep it like that. Now, understanding the other one. So if you look here in this expression, what we have 6 and 13 as the factors. Okay. Now we are going to check for the other one. So the next one, we have 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. Okay. Now look at the question. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. So we have to explain why this number and this number are composite numbers. So so first number we found out its factorization. So what we can say about this particular number, we have 13 and 6 as the factors. It's not just 1 and itself, right? So we can write 6 and 13 are factors. So it is composite. Okay, in composite numbers we have other factors other than 1 and itself. So here also we can say that there are other factors than 1 and itself. So this is 1. So this first part is composite. Now we are checking for the second one. Now this expression also have 5 here and 5 here. We can do the same like the previous one. We are taking 5 outside. Now in the first one we have 7 into 6 into 4 into 3 into 2 into 1 plus, in the second factor we only have 1 is the factor. So here we have to multiply all these. So this will be like 5 into, when you multiply all these 7 into 6, it's 42, 42 into 4, like that. If you do, you will get 1008. Now on the second term we have 1, so plus 1. So this is 5 into 1009. Okay, so here 1009, it cannot be factorized further, it is a prime number. But the given expression, it has 5 and 1009 as its factors. It is not 1 and itself. If it is only 1 into 1009, we can say it's a prime number. But here we have 5 as the factor, so we can say it is a composite number. It has the factors. So the given expression has 5 and 1009 as factors. So what we can say that it is a composite number. Hence, it is a composite number. Okay. So that's about our sixth question. I hope it is clear. Now moving to the seventh question. So we have a circular path around a sports field. So what we have a sports field, and along this sports field we have a circular path. Sonia takes 18 minutes. Okay, Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? So in this case, in this kind of questions where, okay, here its time is given, sometimes other measurements can be given. So what you have to do in this question is that you have to find the LCM. In this kind of questions, you have to find the LCMs. So when you find the LCM, you will find out the time. We can calculate the time at which they meet again. So if you analyze the times, we can say that Sonia takes 18 minutes, whereas Ravi takes 12 minutes. Okay, so they are traveling in the same direction. Okay, so if you see here, Ravi takes lesser time than Sonia for completing one round. So for completing this one round, Ravi takes lesser time than Sonia. So as they are going in the same direction, they will meet again at the same time when Ravi will have completed one round of the circular path. So this will be the LCM of the time taken by Sonia and Ravi for completing one round. Okay, so what we have to find out, LCM of 12 and 18 minutes. So these are the time taken by them to complete one round. So let's factorize 18. 18 we can write it as 2 into 3 into 3. And 12 we can write it as 2 into 2 into 3. Now, if we need to find out the LCM of 12 and 18. Now, what are the common factors here? 3 and 2 are the common factors. So this is one pair and this is another pair. Okay, so we will take 1 2 from this, so 2, and 1 3 from this. Okay, so I took one factor from the common factors. Now what is left? We have to take the other two, that is 3 into 2. Whatever is left, we just write it like that. So here what we have 4 into 9, which is 36. So it's 36 minutes, the LCM. So therefore the Ravi and Sonia will meet together at the starting point after 36 minutes. They meet after 36 minutes. Okay. So I hope this is clear for you.